Hello friends. So let us talk about universal principle of design. Now, we define universal principle as the design process, the process of designing products so that they can be used by many people as possible in many situations as possible. But what does this mean in practice? Is it possible to design anything so that anyone can use it? No, it is somewhat irrelevant. It can be aim of universal design and try to provide an equivalent experience. So we have uh, they they were intended to cover all areas of design and equally applicable to the design of the interactive system. This principle gives us a framework in which to develop universal design. So principle one is equitable use. The design is useful to people with a range of abilities and appealing to all. No user is excluded or stigmatized. So wherever possible, access should be the same for all. When identical use is not possible, equivalent use should be supported. Now, principle two is flexibility in use. So the design allows for a range of ability and preference to the choice of methods of use and adaptivity to the user's space, precision, and custom. Principle 3. It is the system be simple and initiative to use, regardless of the knowledge, experience, language, or level of concentration of the user. The design needs to support the user expectations and accommodate different languages and literacy skills. So it should not be necessary that complex and should be organized and facilitate access to the most important areas. Then you have a principle 4 is perceptible informations. That means the design should provide effective communication for informations. Presentation should support the range of devices, techniques used to access information by people with different sensory abilities. Like if the people have a disabilities, if the peoples have different types of sensory abilities. Now, principle 5 is tolerance for error, minimizing the impact and damage caused by mistakes or unintended behavior. Potentially dangerous situations should be removed or made hard to touch. Potential hazards should be shielded by warning. System should fail safe from the user's perspective. Principle 6 is low physical effort. The system should be designed to be comfortable to use, minimizing physical effort and fatigue. The physical design of the system should allow the user to maintain a natural posture with a reasonable operating effort. Principle 7 requires size and space for the approach and use. So, the placement of the system should be such that it should be reached and used by the user regardless of body size, posture, mobility. All physical components should be comfortably reachable by sitting or standing users. System should allow for variation in hand and size and provide enough room for assistive device to be used. So these seven principles give us a good starting point in considering universal design. They are not equally applicable to all situations, of course. For example, principle 6 and 7 would be vital in designing an information booth, but less important designing a word processing software. Next is multimodal interactions. So multimodal interaction is providing access to information through more than one of the interaction is important principle. Providing access to information through more than one mode of interaction is an important principle of universal design is the multimodal interactions. So we have five senses like light, sound, touch, taste, and smell. So sight is predominant sense for the majority of people and most interactive. System consequently use the visual channel as the primary means of presentation through graphic, text, video, and animations. Then we have touch, all the senses we have studied earlier. So we have sound interface. Now sound is an important contributor to usability, so there is experimental evidence to suggest that addition of audio confirmation of modes in the form of changes key clicks reduce errors. So video games offer further evidence since expert tends to score less well when the sound is turned off than when it is on. They pick up vital clues and information from the sound while concentrating their visual attention on different things. The dual presentation of information through sound and vision supports universal design. Then speech in the interface. Now language in rich and complex. We learn speech naturally as children. For example, they try to listen and they how cutely when they speak. Did you hear when the children who are 3 years and 4 years when they hardly learn to talk, how sweet is their voice, so how the speech improves. So this process seems to so effortless that we often do not appropriate in a complex structures. Now, structure of a speech. Now, speech is as the interface. So we have a structure of a speech. We are fully to appreciate the problems involved with the computer-based recognition and generation of speech. We need first to understand the basic structure of speech. Then, even being able to decompose sentence to the basic part does not mean that we don't understand them. Syntax, the structure, the syntax only serve as a standing and foundation upon the semantic that the meaning is based. We are rarely aware of the complex structure of the speech and concentrate on extracting the meaning from the sentence. Speech recognitions. There have been many attempts in developing speech recognition system, but although commercial systems are now commonly and cheaply available, the complexity of language is one barrier to success, but there are other more practical problems. Background noise can interfere with the input, masking or distorting the information. The more serious still is the problem posed by different languages. Everything from phonemes up can be different. Speech recognition offer another mode of communication that may be used to supplement existing channel or be the primary one. When the user's hands are already occupied, such as factory, speech may prove to be the ideal input medium. Speech synthesis. Complementary to speech recognition is speech synthesis. The notion of being able to converse naturally with a computer is an appealing one for many users. So synthesized speech also brings other problems like being transient, spoken output cannot be viewed or browsed easily. It is intrusive, requiring either in increasing the noise in the office environment with the or the use of headphone, either which may be to have a low price but the benefits of the system may offer. Speech synthesis is also useful as a communication tool to assist people with the physical disabilities that affect their speech. Here, speech synthesis needs to produce output that is as natural as possible. Most human communication tool of this type use predefined messages. Then we have uninterrupted speech. So uninterrupted speech is speech does not have to be recognized by a computer to be useful in the interface. Fixed pre-recorded message can be used to supplement or replace visual information. How it is useful, like when you call someone, so there's a pre-recorded message like um, the number you have dialed. So this is a pre-recorded. Recordings have a natural human prosody and communication. Recording of user speech can be also be very useful, especially in collaborative application. For example, many readers will have using a voicemail system. Also, recording can be attached to another artifact as a recordio annotation in order to communicate with other or to remind oneself at a later time. Digital signal processing techniques can accelerate recording while keeping the same speech. Speech can be played back up to the twice the normal rate without any loss of comprehensibility. The operator may often begin to act on a message while it is still playing, hence reducing any gain from the faster playback. Non-speech sound. Now we have considered the use of speech in the interface. As a speech is serial, we have to listen to most of the sentence before we understand what is being said. Non-speech sound often be assimilated much more quickly. Speech is a language dependent. A speech-based system requires translation for it may be used for another language group. The meaning of non-speech sounds can be learned regardless of a language. Speech requires the user attention. Non-speech sound can make use of phenomenon of auditory adoption. Background sounds are ignored unless they change or case. Non-speech sound can be used in a number of ways in interactive system. It is often used to provide transitory information such as indication of network or system changes or error. Non-speech sound can also be used to provide a second representation of actions and objects in the interface to support the visual mode. Then you have auditory icons. Auditory icons uses the natural sounds to represent the different types of objects and actions in the interface. The For Magnetosh was developed for this idea to enhance interference to redundancy. Natural sounds are used because people recognize the source of sound and its behavior rather than timbre and pitch. For example, a noise will be identified as a glass breaking or a hollow pipe tap. However, the advantage also creates a problem for auditory icons. Some objects' actions do not have obvious, natural occurring sounds that identify them. Then we have ear cons. So what is ear cons? Ear cons use structured combination of notes called motifs. Have you ever seen how the music is prepared? There are the music notes, and accordingly, the music, the sound, how the sound is created, how the music is created. In the same way, it represents the action and object. They are very according to rhythm, pitch, timbre, and scale and volume. So there are two types of combination of ear con. Compound ear con combines different motifs to build up specific action. For example, combining the motives of create and file. Family earcons represent compound earcons of similar types. As an example, operating system errors and syntax error would be in the error family. In the way, earcons can be hierarchically structured to represent menus. Earcons are easily grouped and refined owing to the compositional and hierarchical nature. So, earcon provides a structural approach to design sound for the interface but can use the sound adequately, and the factor influence is evidence suggests that people learn to recognize the earphones. Then we have touch in the interface. Now we the use of touch we have already seen, like in the first chapter. The use of touch is the interface is known as haptic interaction. So haptic is a generic term for touch. Now we consider now yes, this we have studied, like the skin, whether it is hot, whether it is cold. So how the vibration against the skin is cutaneous and other resistance of feedback is kinesthetic. They facilitate perception of properties such as shape, structure, resistance, as well as temperature. This means the haptic the haptic has the fields to we provide information on the character of objects in the interface as well as more realistic simulation. So, of the textile device, tactile device is an electronic or soft is beryl device. A beryl display a number of cells, typically 80-20. So each containing 6 or 8 electronically controlled pins that move up and down to produce beryl representations. Then you have next is handwriting recognitions. Now handwriting recognitions is like the speech we consider the handwriting for a natural power for communication. The idea of being able to interpret handwriting input is very appealing and handwriting appears to offer both textual and graphical input using the same tool. So there are problems associated with the use of handwriting as an input medium. So technology of handwriting recognitions is the major piece of technology used to capture handwriting is digitizing tablet. Free-flowing stroke made with the plane are transformed into a series of coordinates approximately one every 1/50th of the second. Rapid movements produce widely spaced dots in the comparison with slow movements. This introduces immediate errors into the information. Then recognizing handwriting. Gesture recognition. Okay, recognizing handwriting will do it. The variation between the handwriting of individual is large, so everyone has a different handwriting, a unique handwriting. No one copies to each other. However, the problems are reminiscent of those or in that we discussed in the speech recognition. The equivalent of co-articulation is also prevalent in handwriting, since different letters are written differently according to preceding and successive ones. So this causes problem for recognition system which try to identify the lines, the content text, and then to segment the digitized image into separate character. Then you have a gesture recognition. Now, gesture is a component of human computer interaction that has become the subject of attention of multimodal system. Being able to control the computer with a certain movement of the hand would be advantageous in many situations. So, it would also support communication for people who have hearing loss, A signing could be translated into speech or vice versa, but like speech, gestures user dependent, subject to variation and co-articulation. The technology of capturing gesture is expensive using either computer vision or a special data glove. The data glove provides easy access to high accurate information but is relatively intrusive technology. Uh, The media room at MIT uses a different approach in order to incorporate gesture in the interaction room. Then you have a designing for diversity. Now, designing for diversity is considered briefly for some factors and particularly challenges. So, this in this we'll discuss about the disability, age, and culture. So, first is designing for the user with disability. Then we have visual impairment, no, the sensory impairment that has attracted. I'm sorry, the eight is not that. The eight is not included. The eight I have written it by mistake. Only we have a seven. I'm sorry for that. The senses. So let us continue with the visual impairment. The sensory impairment that has attracted the most attention for research, perhaps because it has potentially allowed the use of deliberation deliberating as far as interaction is concerned is visual impairment, the one who cannot see. So in text-based interaction, screen readers uses synthesized speech or barrel output device provides complete access to computer input relied on touch typing, with this mechanism providing the output. The number of systems are sound to provide access to graphical interface for the people with the visual impairment. Then soundtrack. So with the help of the sound, they can hear with the help of like tick, beep, and so because this visual impairment they cannot see. So the things which have to be built accordingly, they can feel and they can do it. So major limitation of this application was the fact that it was a specialized system. Then you have next is hearing impaired. That means about the deaf. This is about the deaf. So one who cannot hear. That means compared with the visual disability, we have the impact on interacting with the graphical interface. Now when I cannot hear, but I can interface. I know because I if I click this, what will happen? I can manipulate and operate. But gesture recognition has been proposed to enable translation of signing to speech or text given to improve communication, particularly with non-signers. Now, if the person is born as a hearing impaired or by accident the person is hearing impaired till then the person was able to read, could hear any everything, and so the person will able to access this. How that person will access this? Because there are things like if that person able to read, he or she that person can do it. But if the person is born with this disability, so that person has been taught up with they has been brought up or taught up with the explanation with the reading skill, so that at least that person can read and can do it. But the increase in multimedia and sound or use of sound in interface has been ironically created and some access difficulty for people with hearing problem. Many multimedia presentation contains auditory narrative, so they can hear it even if I don't want to hear. I want to hear my PDF aloud. I don't want to say it. I can do it. But those people who have this deficiency, what they can do is they can at least read it. So email and instant messaging are great levers can be used to bring up hearing and deaf users alike. Then you have a physical impairment, like physical impairment users with physical disabilities like without arms, without feet, without legs. So that means speech input and output is an option for those without speech difficulties, and they could hear it also. But how can they operate the mouse, the keyboards? So if the user is unable to control head movement, just movement tracking can be used to allow user control. If the user has limited use of keyboard, a predictive system such as a reactive keyboard can help by anticipating the commands that are being typed. Predictions are based on what the user has been used, what the user want to use. So predictions user has typed in the current session or in the previous sessions. Next is speech impairment like the dumb. like for those who cannot talk. So for users with speech and hearing impairment, multimedia system has provided a number of tools and communication, including synthetic speech and text-based communication and conferencing system. So textual communication is slow, but which can offer the effectiveness of communication. Predictive algorithms have used to anticipate the words used and fill them in to reduce the amount of typing required. Then dyslexia. So I mean, this is one of the deformative users with cognitive disabilities, such as they cannot able to read it, can find textual information difficult. In severe cases, speech input and output can alleviate that need to read and write and allow more accurate input and output. So consistent navigation structure and clear signposting cues are important to people with dyslexia. Color coding information can help. They are very fond of colors, so color coding can help them in some cases and provision for graphical information system. Then another is autism. So autism affect a person's ability to communicate and interact with people around and them to take into the sense of environment. So social interaction is like problem in relating to other in meaningful way or in responding appropriately to social situation. Communication like problems in understanding the verbal and textual language. Then imagination problem with rigidity of thought process which may lead to repetitive behavior and inflexibility. So communication and social interaction are major areas difficulty for the people with autism. Computers on the other hand are motivating for perhaps people because they are relatively consistent, predictable, and impersonal in their responses. Computer can may also play a role in education of children with autism, particularly by enabling them to experience to virtual environments and games, social situation, and learn appropriate responses. Then you have designing for the age of older people and children. So, how the interactive systems designed for the older people, let us say. So, the proportion of the older people is the population is growing steadily. People are living longer but have more leisure time. They have more spare time and disposable income. And older people have increased their independence. The factors have all led to an increase in the old users. But the requirements of old population may differ significantly from the other population group. So, just in younger people have with disabilities, technology can provide support for the failing vision, hearing, speech, and mobility. So, new communication tools such as email instant messaging can provide social interaction in cases where lack of mobility or speech difficulty reduce face-to-face possibilities. Even old user, while not averse to use technology, may lack familiarity with it. Then you have about the children. So below 12, I mean, requirements of 3-year-old children will be quite different from those as 12 years old children. So children are however different from adults. They have their own goals, likes, and dislikes. So it is therefore important to involve them in the design of interactive system and that they are for their use. This is itself can be challenging as they may not be shared designer vocabulary or be able to verbalize what they think. Design approach have therefore been developed specifically to include children actively as members of the design team. So team members including children use as a range of sketching, note-taking techniques to record their observation. Paper prototyping is used as an art tool familiar to children, enables both adults and children to participate in building and refining prototypes. The approach has been used effectively to develop a range of new technologies for the children. Then, at last, we have the designing for cultural difference. Now, the final area of diversity we will consider in cultural difference. So, cultural difference is a synonym with national difference, but this is too simplistic. With all the contributions of a person's cultural identity, they will not be able to use a relevant in the design of a given system. We can draw out some key factors that we need to consider carefully. Similarly, symbols have different meaning in different cultures. As we say, tick and crosses. So ticks represent positive and negative respectively, but in some cultures they are interchangeably in others. The rainbow of the symbol of covenant with God in Judeo and Christian religions of diversity. We cannot assume that everyone will interpret symbols in the same way and should ensure that alternative meaning of symbols will create problems or confusion for the users. So, where diversity can cause misunderstanding, it is the use of gesture. Recently, one of the author was teaching new class of international students and was disconcerted to see one sitting in the front row smiling and shaking his head. After the lecture, the student came and asked a question. So every time the author asked the student, he understood the explanation. He shook his head. So further explanation ensued, much to the frustration of the student. It was only after a few minutes it became clear that it became clear. Use of gesture is quite common in video and animation, and care must be taken with difference such as this. So, and interact as interaction is being incorporate begin to incorporate with gesture, it is a in virtual reality and avatar issues such as like okay, you have seen the avatar movie, and so the avatar comes up. So that define the diversion, the cultural difference would come up. We need to resolve it. So we need to ideally we need to generalize in the same way so that this issue could not come up.